In today's world of shrinking electronics, high-density batteries, and advanced aerospace systems, thermal management is everything. As devices get smaller, engineers turn to thin film materials, just fractions of millimeter thick, to control heat flow. But here's the problem. Most of the time, thermal data for these thin films comes straight from vendor data sheets or is assumed from bulk material properties. Those numbers rarely match reality when you're working at micrometer scales. Take the case of one R&D team designing a next-generation battery. They needed to validate the through-thickness thermal conductivity of a pyrolytic graphite sheet, only 0.15 millimeters thick. On paper, the data sheet boasted incredible in-plane conductivity, perfect for spreading heat laterally. But when it came to out-of-plane or through-thickness behavior, the data was missing. Without those numbers, their thermal models and safety margins against thermal runaway were built on assumptions. And when you're talking about lithium-ion batteries, assumptions equal risk. That's where the solution comes in. The team turned to the Thermtest guarded heat flow meter, the GHFM-01. Following the ASTM E1530-19 standard, they set up a layered test method. By stacking the graphite sheets in progressively thicker assemblies from 5 up to 23 layers. They built a linear relationship between sample thickness and measured thermal resistance. Because the GHFM-01 uses a guarded heat flow configuration, lateral heat losses were minimized. The measurement captured the true through-thickness behavior of the graphite sheet. The analysis revealed a thermal resistivity of 0.2404 millikelvins per watt, which translates to a through-thickness conductivity of 4.16 watts per meter Kelvin. Compare that with its in-plane conductivity of 486 watts per meter Kelvin, a difference of more than 100 times. The data was clear. This material was excellent at spreading heat across its surface, but far less effective at conducting heat through its thickness. And here's the takeaway. In thin film thermal management, direction matters. Relying on bulk or in-plane numbers to model through-thickness performance can massively under- or overestimate how heat actually flows. That leads to poor designs, underestimated risks, and wasted resources. With Thermtest GHFM-01, engineers have a direct, standards-based method to measure ultra-thin sheets and coatings accurately. Instead of guessing, they get precise numbers that they can trust. Armed with this data, the battery R&D team could model heat transfer correctly, validate their safety margins, and design with confidence. Whether it's batteries, microelectronics, or aerospace systems, the lesson is the same. When it comes to thin films, don't assume, measure.